This is lesson 4-5, compound inequalities. A compound inequality is two inequalities joined by the word and or the word or. For example, if you came home and said, "Hey, Mom, what's for dinner?" And she said, "We're having hamburgers and hot dogs for dinner." When you sat down at the dinner table, you would expect to see hamburgers on the table and hot dogs on the table because it was an and statement. It means both must be present. But if you came home and said, "Hey, Mom, what's for dinner?" and she said, "We're having hamburgers or hot dogs for dinner." When you sat down for dinner, you'd expect one or the other to be on the dinner table, not both. You can write compound inequalities, especially compound inequalities with the word and, together as one inequality. For example, if you have x is greater than or equal to -5 and x is less than or equal to 7, you can rewrite that inequality so it is a compound inequality where it says -5 is less than x, which is less than or equal to 7. Literally what this means is x is between -5 and +7, because literally it falls in between those two particular numbers. Whenever you write a compound inequality with the word and as a single inequality, you must make sure that your inequality symbols face the same direction. You cannot have one inequality symbol facing one direction and the other inequality symbol facing the other direction. If we wanted to make a compound inequality, to write a compound inequality that represents something, let's look at this first example here. All real numbers greater than -2 but less than 9. Literally what that means is I have all my numbers are greater than -2 but less than 9, which means anything between -2 and 9, not including -2 and not including 9, which means I have to write my inequality. X is my variable, is greater than -2 but less than 9. You read it from the inside out. You read going left and then you read going right. If I was to graph this then, to graph this inequality, here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -1, 2, 3, 4, -5. If I am greater than -2, that means I have an open circle at -2, but I'm less than +9, I have an open circle at +9, and I'm going between those two numbers. Only all the numbers between those two numbers, not including -2 and not including +9. X is literally between -2 and 9. Let's look at number 2. The books were priced between $3.50 and $6 inclusive. The word inclusive means including, which means it includes $3.50 and it includes $6. What that means? Closed circle. That's really all the difference is. If it says inclusive, it means it does include that. It means equal to those values as well. So my books were priced between $3.50 and $6. So X is greater than or equal to $3.50, but less than or equal to $6. Remember, the smaller number always goes on the left-hand side, and the larger number always goes on the right-hand side. Very easy to do if you remember. Like a number line, smaller numbers are on the left, and larger numbers are on the right. If we're going to graph this, here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's greater than or equal to $3.50. 1, 2, here's 3. $3.50 would be halfway through. It's a closed circle. But less than $6. $6 would be right here. And it's all the numbers between those. All the prices between those two numbers. So writing an inequality is not all that complicated. The solution of a compound inequality joined by and is any number that makes both inequalities true simultaneously. One way you can solve a compound inequality is by writing two inequalities. Another way is by working on all three parts of the inequality at the same time. You work to get the variable alone between the inequality symbols. I'm going to work these both ways, so you can choose which way works best for you. If I'm going to solve and graph, -6 is less than or equal to 3x, which is less than or equal to 15. If I separated this is an and statement. because it does not have the word or. If it doesn't have the word or and it has two inequality symbols, it must be an and statement. If I separated it, I would have negative 6 is less than or equal to 3x, and 3x is less than or equal to 15. You can just rewrite them separately, and then solve them as usual. So I can divide by 3, divide by 3. So I get negative 2 is less than or equal to x, and if I divide by 3 here, x is less than or equal to 5. Okay, so negative 2 is less than or equal to x, or x is greater than or equal to negative 2, but less than or equal to 5. Okay, since it's an and statement, I could graph this. There's 0, there's 5, there's negative 5. So it's greater than or equal to negative 2, which would be going greater than or equal to is closed circle. It's going to go that way. Less than or equal to 5, closed circle, goes this way until they match. Now I can do the same thing with the same inequality, but I can solve it all at once. I'm going to do this in green so you can see it. All I would have to do here is I'm going to divide by 3 here. I divide by 3 on this side of this part of the inequality. I divide by 3 on this side of that inequality. So you get negative 2 is less than or equal to x, which is less than or equal to 5. Exactly the same thing I got there, but written as a single inequality versus written with the word and. It's your choice which way you want to do that, do the inequality. I have a tendency to use this second method because it's faster, and I don't have to worry about forgetting things or transposing things. Let's look at question number 2 here. Before I can start doing anything, I have to make sure I undo any addition or subtraction first. They subtracted 1 from 2x, so I need to add 1 to here. I need to add it to this side of the inequality. I also needed to add it to the other side of the inequality, so we should do it 3 times. It cancels out here, leaving me with 2x. 2x is greater than negative 3 plus 1 is negative 2, and less than 7 plus 1, which is 8. So I now have negative 2 is less than 2x, which is less than 8. Divide everything by 2, divide the middle by 2, divide the left by 2, divide the right by 2. Since I divided by a positive number, my inequality symbol does not change just because I have a negative answer here. Negative 2 divided by 2 is negative 1, which is less than x, which is less than 4. So x is between negative 1 and 4. So if I was to graph this, there's 0, negative 5, positive 5. X is greater than negative 1, open circle at negative 1, but less than 4, open circle at 4, and a line between the two. Number 3, I need to get rid of the 1 again. So I'm going to subtract 1 from the middle part of the inequality, the right half of the inequality, and the left side of the inequality. So 7 minus 1 is 6, which is less than or equal to negative 3n. These two 1s cancel out, which is less than or equal to 13 minus 1, which is 12. Now to get n by itself, I'm going to divide by negative 3. Since I divided by a negative number, my inequality symbol must switch. 6 divided by negative 3 is negative 2. This changes to greater than or equal to. N, which is greater than or equal to. 12 divided by negative 3 is negative 4. Now that's a little hard to graph because it's kind of written backwards. It says negative 2 is greater than or equal to n, which is greater than or equal to negative 4. Literally, the smaller number should go on the left-hand side. 4 is the smaller number. This is negative 4 is our smaller number here. So it should go on the left-hand side because smaller should be left and bigger should be right. So we should have negative 4. Notice it's open toward the end's in the middle. Okay, your n is still in the middle, and your negative 2 is here. But instead of being the same direction, it's greater than or equal to negative 4, less than or equal to negative 2. Okay, all you had to do when you rewrote it so the smaller number was on the left-hand side and the larger number was on the right-hand side, switch the inequalities. So if I'm going to graph this, and remember all the smaller numbers should go to the left-hand side. This is 0, 1, 2, 3, 4, 5, negative 5, 6, 7, 8, 9, 10, negative 10. So n is greater than or equal to negative 4, which is right here. Less than or equal to negative 2, which is right there, and a line between the two. We can write inequalities and solve them with word problems as well. This is a compound inequality dealing with the word and. Your test grades in science so far are 83 and 87. What possible grades can you make on your next test to have an average between 85 and 90 inclusive? Means it could include 85 and it can include 90. So I need to figure out how to write this inequality. First thing I need to do, I need to define my variable. My variable is my next test grade because it says what is your next test score. So I'm going to let x equal my next test score. And so I will have a total of 3 scores here. So I know that my test 1 plus test 2 plus test 3 divided by 3, because that's what an average means, has got to be greater than or equal to 85, but less than or equal to 90. I want it between an 85 and a 90. So now I just need to transpose all of those numbers into parts of the equation. So I'll keep the 85. Less than or equal to, test 1 was an 83. Test 2 was an 87. Test 3 is a we don't know yet, because that's what we're trying to figure out. That average still has to be divided by 3, because I'm going to have 3 total test grades, less than or equal to 90. Okay, so let's simplify this a little bit. If I add 83 and 87, I get 170. So I have 85 is less than or equal to 170 plus x divided by 3, which is less than or equal to 90. I need to get rid of that 3 because the 3 is really, really annoying. Okay? Nobody likes the 3 because nobody likes to deal with fractions. So I'm going to take and multiply everything by 3. Multiply the middle by 3, multiply the left by 3, multiply the right by 3. When I do that, I will get 85 times 3, which is 255, is less than or equal to, these 3's cancel out, so I will have 170 plus x, which is less than or equal to 90 times 3 is 270. Now I have a compound inequality. I simply need to solve for x. So I will subtract 170 from the middle, subtract 170 from the left, subtract 170 from the right. If I take 255 and I subtract 170, I get 85. These cancel, and 270 minus 170 is 100. So in order to have a test average, between 85 and 90, I must score between 85 and 100. So my last test must be scored between 85 and 100 points. And of course, since it can equal 85 and it can equal 100, you need to use the word inclusive. I must score between 85 and 100 points inclusive. Let's take a look at another type of inequality. Compound inequality with an OR. A solution of a compound inequality joined by OR is any number that makes either inequality true. One or the other does not necessarily have to be both. Okay? This is the hot dog and hamburger thing. You don't expect to see both the hot dogs and the hamburgers when you sit down if your mom said you're going to have one or the other. So to write a compound inequality that represents each situation, we're going to graph all real numbers that are less than 0 or greater than 3. Numbers that are less than 0 or greater than 3. So I can say x is less than 0 or x is greater than 3. You have to put the word in there. You must have the word or. You can't leave it blank. You can't just put the two inequalities there. You actually have to write the word or. X is less than 0 or x is greater than 3. To graph this inequality, x is less than 0, means I have an open circle at 0, line goes to the left, that's less than 0. X is greater than 3, open circle at 3, line to the right. Most of the time, your OR inequalities will go in opposite directions. Only once in a while will they head toward each other, and then they become an AND inequality in the process. That happens very rarely. Let's take a look at this second one. Discounted tickets are available to children under 7 years old or to adults 65 and older. Okay? Children under 7, meaning not including 7. Under 7 would be x is less than 7. But adults 65 and older, so x is greater than or equal to 65. They can be 65 or they can be older. Now we need to make sure we add the word or in the middle there. So x is less than 7 or x is greater than or equal to 65. Huge swing in numbers here. So you might want to just not draw every number from 0 to 65 and just do this. Here's 7. Let's say I make this be 10. Let's see, 20, 30, 40, 50, 60. This would be 70, so 65 would be about right here in the middle. So x is less than 7, open circle at 7, line to the left. X is greater than or equal to 65, close circle at 65, line to the right. And you don't have to graph by 1 because that would take a ridiculous amount of paper. Alright, for a compound inequality joined by OR, you must solve each of the two inequalities separately and use the word OR. So if we're going to solve these, negative 2x plus 7 is greater than 3, or 3x minus 4 is greater than or equal to 5. You're simply going to solve each one of these two inequalities individually. So a negative 2x plus 7 is greater than 3, I need to subtract the 7, So negative 2x, those cancel, is greater than 3 minus 7 is negative 4. Divide by negative 2. And x, we divide by a negative number, so our inequality sign switches, is less than 2. That's part of it. Now we need the other part. Over here, I will add 4 to both sides. So I will get 3x, these cancel out, is greater than or equal to 9. Divide by 3, divide by 3. X is greater than or equal to 3. Put the word OR in between. So x is less than 2, or x is greater than or equal to 3. I would graph this. X is less than 2, open circle at 2, line to the left, or x is greater than or equal to 3, close circle at 3, line to the right. And that's the inequality and the solution to it with its graph. 3x plus 2 is less than 7, or negative 4x plus 5 is less than 1. Again, solve each inequality separately, so I'll subtract 2 here, subtract 2 here. I get 3x, these 2's cancel out, is less than 7 minus 2 is 5. Divide by 3. X is less than 5/3. You can change that to a mixed number if you would prefer. It would be 1 2/3. Or here, the second one, subtract 5, subtract 5. You're going to have negative 4x. These will cancel, is less than negative 4. So divide by negative 4, divide by negative 4. X is less than negative 1. Okay, I have a mistake in this problem. Let's go back and erase this. This first one here has a typographical error. Second one is fine. This should be a negative sign in front of my 7. Wrong problem. There we go. Now 3x plus 2 is less than negative 7. That would be much better. Same process. I'm going to subtract 2, subtract 2. I will have 3x is less than negative 9. Divide by 3, divide by 3. X is less than negative 3. Okay, so x is less than negative 3. We did make a mistake in the second part. We forgot to flip our inequality symbol right there. So this would be x is greater than negative 1. Not that one. I missed the negative sign. So we forgot to flip. I knew this was wrong because I knew the two inequalities could not face the same direction and have an or in them. So we now have x is less than -3 or x is greater than -1. Now we finally have it correct. To graph this, x is less than -3, open circle at -3, line left. X is greater than -1, open circle at -1, line right. And there you have compound inequalities.